The next circuit that we're going to build is the one that matches the expression z plus complement of x plus y. So again, we're going to do the first things first, right? And so the first thing we do is inside the parentheses. So we have x plus y, and a plus is an OR gate. So we take x and y and feed those into the OR gate. That gives us the x plus y. The next thing we do is the complement, and this is how we're doing everything under the complement bar first. That's what's in the parentheses. And the complement is a NOT gate, so we take the output of that, the x plus y, and that's the input to the NOT gate, and that's how we get that complement. The next one that we do is, that gives us everything on the right is done. Now we need to do the z plus, and now we're doing z plus all this other result. So what that turns out, how that works is the plus is an OR gate. So we bring an OR gate over here, and one input is going to come all the way from the z, and the other input is going to go from the result of that NOT gate. So there, we've put everything together that's in there. We just followed the order of operations, and now we can find out when that light bulb comes on. Now, to do that, we want to compare to verify what do we expect here. So here again, I built this table and executed things in the order, by order of operations, and I ended up with lots of ones on this one. So we might have to go back and forth between them. So we expect the first two to the light to be on. So that's when, oh, sure enough, when they're all zeros, the light is on. And when the 2 zeros and z is 1, the light is on. So we've got the first two. Let's look, the next one is a 0, and that's when we have off, on, off. So that would be off, on, off, and sure enough, we got a 0 there. It's not lit up. Then we have a 1 where it's off, on. So off, on, and there it is. There's that 1, the light on that we expected. And here we have 1, or on, off, and we expect it to be off. So on, off, and it's off. That's what we expected. That's awesome. And the next one is on, off, on, and we expect it to be on. So on, off, on, and sure enough, it's on. Yes. Okay, so far so good, right? The next one is on, off, and we expect it to be off. So on, off, and there it is, off. It's really nice to be able to validate this and make sure it's right. And then we have on. So let's see what we get when we have on. That's with all of them on. It's on, which is what we expected. So there we have the result of this Boolean expression, and we've done it as a circuit. Now, go ahead and do this one. So work through this one, make a circuit out of it, and then you can turn it in. Now, the way to turn it in, we can't save in Logically because with the free version, but what you can do is you can just take a screenshot, right? So if you're using Windows, you can use the snip and sketch tool. And I don't know if you can see that. Let me try to get it down in there. So there's the snip and sketch tool, and this comes built in Windows. If you have an older version, you can use the snipping tool. And in Mac, there's also tools that you can do a screenshot. So what you do here is you just do new, and then notice what it does. It grays out your screen and gives you this crossbar. And then you just take the crossbar and you capture just the part of the screen that you want. And then it's your image, and that you can save it right here with this icon is just to save it, and you can save it somewhere on your computer, and then you can upload it. So that's how you can turn these in. And then you don't have to save them, and you don't need the free version. And then when you're ready to do another one, you just simply click on it and backspace, and that will get rid of them. And you can do that one at a time. I'm going to leave these because we'll use these on the next one.